Okay, so let's talk about section 1.2, the graphs of functions. In this section, we're going to talk about graphing equations using the point plot method. We're also going to look at graphing it with the calculator, aligning inputs and scaling outputs to model data, as well as graphing data points. So let's start off with our very beginning part here. Let's graph the equation y equals x squared. Now, in order to do this and to draw a smooth curve through these points, what we need is we need a bunch of smaller points to help us through this. So I've given you a beautiful table here, and in the table, I've given you your x values. Now, you can have either an x or a y value. It's normally simpler just to have those x values. Now, if all I gave you was the actual y equals x squared, please understand that basically when we do these types of things, if this is the only thing that's given to you, you kind of need to choose your own x values and find out what the y values are so you can be able to plot them. So for the most part, anything between -3 to +3 are a really good choice here. Now, remember what we're doing is we're basically taking x is -3, so the equation is x squared equals y. So this is going to be -3 squared, which is going to give me 9. And then I'm going to repeat the process for each one of these. So that means I'm going to take -2 and square it, which is going to give me a +4. I'm going to take -1 and square it, which is going to give me a +1. We're going to take 0 and square it. Okay, and that's going to give us 0. We're going to take 1 and square it, which just becomes 1. We've got 2 squared, which is going to give me 4. And then 3 squared is going to give me 9. Now be very careful, especially for like this one, and this one. Now, why I'm saying be careful is because one of the things hopefully you began to notice is as I'm writing these, and this is where a lot of students do make a mistake, is you'll notice that because this number is negative, I am basically plugging it in for x squared. So that's x squared, but itself is negative numbers. So when I plug that in, you'll notice I kind of put parentheses first, put the power of 2 on it, and then put in my -1. So that way I know that I can get the correct answer. And you want to make sure that you're very cautious with this as well when using the calculator. So if I were to type in -1 and then put it to the power of 2, and then if I use parentheses around it and put it to the power of 2, you'll notice I get 2 different answers. And that's because the calculator is seeing it 2 different ways. It's seeing that the negative is included with that power, and the first one here is the negative is not included. This is why when you see professors or teachers put stuff with negative numbers, that's why we always put stuff with parentheses around it, because we do want to make sure that the calculator is calculating it correctly. And the top one here, it's seeing basically a negative times and then 1 being squared, which is a little bit different than -1 itself being squared. Okay, so make sure that you're being very cautious of that as you are going through them. Now that we've got all those points, let's actually graph them. Now, as you graph them, does it matter the order in which you graph? No, not really. But what we do need to know is we know that this horizontal axis is our x, and this nice, lovely vertical axis is our y. Okay, so normally, again, remind yourself this was y equals x squared. So we're kind of plotting those points there. So when x was -3, now I'm going to leave this on kind of each little block represents 1. So this is going to be basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's my beautiful 10. Arrow with me on that. And then that's going to be the same way going the other direction. So this is going to be -10. On your homework, you're going to be able to see that these are already labeled. So they should already have some of these tick marks labeled throughout. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it may not be like every single one. Like you notice I did not label every single one here. I only labeled a couple of them. And that's just to kind of make my life a little bit easier, because otherwise it does get a little tedious as you are trying to write all these out. So what I do suggest is basically when you're doing these, make note of whatever these numbers are. So in our case here, if this said 20, then that means every single one of these tick marks would go up by 2 to get to our -20. So you really want to be cautious there. Okay, now that they're all labeled, I'm going to go ahead and draw. And you'll notice that normally when we draw these, we start with any point, but we always start at the origin, which is the 0, 0 point. Now, I am going to go over 3. So 1, 2, 3 to the left. So here's my -3. And remember, it went up to a +9. And I'm just going to put that point right there. Okay. And then again, we're going to go to -2 and then remind yourself that -2 squared gave us a positive y value of 4, which would be about right there. And then at -1, it was 1. Then we had 0, which was 0. Okay. And then with +1, it was 1. At +2, it was 4. And then at +3, it was 9. Okay. Now, with all of those, let's go ahead and draw a line that connects them all together. Now, please forgive me for drawing because I am actually drawing with a pencil here. So my line is not perfect. I tried really hard. Okay, let's try that one more time. So as you guys are drawing, it's a little bit easier when you can draw it on hand, when you don't have to like freehand it. I am literally looking at a computer screen trying to draw this, and you guys get the idea. Okay, so it's there and you've kind of drawn it. When you are looking at your homework, make sure to kind of look at the side and see, does it give you options? So when you're using your homework to draw, you're not having to freestyle hand these, okay? What you're going to look at is there's going to be kind of little boxes, and they're going to ask you kind of the general shape. So one of them is going to look like a straight line. One of them is going to have a bit of a curve. One of them is going to look like this, okay? And basically, when you take a peek at those, this one here is going to be for your linears. This is going to be for your curves. So this one I would click on. I would actually click this one if I was to do this drawing. So I would click here and then I would hit my mouse with those points. Okay. This one here is going to be for things that are a little bit more along the lines of like that x to the third and things like that. Okay, so let's talk about a complete graph. And you're going to begin to hear people say this word a little bit, and you're definitely going to see it in the homework as well as throughout books when they talk about, do you see the complete graph? Now, a complete graph should show you the basic shape of the graph, and it's important on the graphs to include any points where it may cross an x-axis or a y-axis and any turning points. Okay, and we should be able to kind of dictate kind of what it should be looking at here. Now, to see a complete graph, you might have to kind of zoom out or zoom in depending on what it is. And this is where it gets a little complicated to find the complete graph, but it's totally doable. So we're going to sketch a complete graph for the equation x to the third minus 3x using the fact that we know, and you guys may not know just yet, but eventually we'll learn why this is true. X to the third minus 3x actually has 2 turning points. Okay, so we're going to use the table to determine some of this. So let's start with our beautiful table there. And again, we are going to find those points. Now, to kind of help us out, do this a little bit quicker than having to do it by hand every single time. And you are allowed a calculator in this course, so we might as well use that calculator, right? So definitely what I'm going to do is I'm going to pull up my calculator here, and I'm going to show you a little trick. So one of the first things we learn about in math is to try to use this calculator a little bit. So I'm going to turn it on. So it's on. This right here is called the home screen here. And in my home screen, I'm going to go up to y equals. Okay. I'm going to use y equals because remember, f of x is the same thing as y. Now we can still do this by hand. So I can take -2 and plug it in for each one of those x's and see what I get out. Okay. So I can do that in the home screen here by just plugging in -2. Raise it to the third power, subtract 3x, which again, x is now being replaced with -2. And I get that that answer there was -2. Okay, so we can do it that way, or we can kind of use this graphing part. Now in the graphing part, what I'm going to do is I'm going to hit this button right here that says xt theta n. That's going to be my variable button. So anytime I talk about variable buttons, that's what I'm meaning. I'm going to raise it to the third power. And then I'm going to subtract a 3 and then x, okay? Now, what I'm going to do is I'm not actually going to look at the graph just yet because I don't want to eyeball anything. I want exact answers. So what I'm going to do is I'm going to hit second graph. And you'll notice in second graph, I'm going to go to the table. Now, right now, my table is like way off in the super high levels. So I can sit here and I can scroll all day long, or I'm going to do a quick way. So I'm going to go to the table setup here. So second window right above it in blue is table setup. And I want to start it right at -2 because that's where my first point is. And then the little triangle tells me how much it should change by. So we're just going to do -2, so it's going to change by 1 every time. So when I go back to that table, so second graph, you'll notice here's my -2. Here we get our y value is +2, y value here is 0, then our -2, and then +2. Okay, so we're able to see what each one of those numbers is. Okay, now as you guys are looking at this, and again, that's kind of really cool, is you're going to refer back to this quite a bit. And this is a nice little trick, hopefully, that you can remember. Like I said, it's definitely very, very helpful. Now, did I have to only do between -2 and 2? No, I could have chosen -3. I could have chosen +3. I could choose 5. You kind of have a lot of turning, a lot of wiggle room to kind of make how many points you want. And the more points, the better. Now, just remember that this was the X, and then when we plugged it in, this was the Y value we got out. But these are the ordered pairs for which I am going to plot on my graph itself, okay? So the points that I'm creating came from this lovely equation right here that they asked us to. Now we're going to see whether or not it has that many turning points, okay? So let's take a peek at this and let's see what the graph looks like now. Now, as we sketch the graph, it should have at least 2 turning points. Now you'll notice that really I only need to see between 5 and -5, and I can see that there is kind of that turning point. And we kind of saw that when we said that we went from, you know, basically a +2y value to a -2y value and vice versa on the other side. It was kind of a little, we could see that up or down movement in the numbers, but we had that kind of layout that we can see there. Now you can't always use your calculator. If you need to see that in the calculator, if you hit the graph button, you should be able to see it. Now, just in case you're not seeing exactly what I'm seeing, double check to make sure your y equals looks just like mine. Remember, this is my variable button that I use for X. And then just hit zoom and 6, and that's going to take you to like the basic window that you'll need for most things, okay? But you can also still graph it by hand, and that works as well. Okay, and I can see, again, I told you it had 2 turning points, so we can see there that it has the 2 turning points here, and there we have it. We have a complete graph in the view. Now, to use the graphing calculator to draw the graph, we're going to go a little bit further into detail. I kind of quickly went over stuff, but again, there's a lot more to it. So the first thing you want to do is you want to write the function with X representing the independent variable and Y being the other variable, which is just a really fancy way. And again, we don't always say it this way, but really it's just a fancy way of saying solve for Y, because that's the button we have in the calculator. So remember, we're basically hitting Y equals, and if the equation doesn't say Y equals, we need to do a bit of work. Okay, you're going to enter that function in. Again, you might need to use some parentheses. And then what we want to do is we want to click activate the graphing by hitting basically the graph button, but we might have to hit the zoom button first. As you saw last time, I said that was kind of something that you might want to do, okay? And the reason why I say that is because a lot of times with our graphing calculator, we're going to be playing with that window a little bit, and we might need to change the view of it. So let's talk about the standard viewing window. Now, the standard viewing window is basically from 10 in the positive direction and 10 in the negative direction. And we go both on the X's and the Y's. This means that the graph will only show between these values. Now, this is kind of the standard window. Now, this is what I would say when I was saying earlier when I said zoom. Okay, so you hit that zoom button, and then the number 6, which in our case there was basically, I believe it's written as Z standard. okay? Just so you guys can see it there, I'll bring up the calculator by what I mean by that. So earlier I said hit the zoom button, and then number 6 here, it says Z standard. That is what we mean by it's basically our beautiful window there that's here's from -10 to +10, both in the X and Y directions. Again, this may not be the ideal. And so with that being said, we do have to sometimes play with it a little bit to determine what would be the best type of window that we might have, okay? So let's sketch the graph x to the third minus 3x squared minus 13. And we're going to do two things. We're going to do one with the standard window, and then we're going to do some adjusting on the window, okay? So let's start with the standard window first. Okay, so let's bring that calculator on back. Okay, and we start with going to y equals. Let me pull it to this side so we can see our equation here. Now I have something already in here, so what I'm going to do is I'm going to hit the clear button. Okay, and we're going to start fresh. So we've got x power 3 minus 3x. Now I can always hit the caret symbol to hit the power of 2, but there's this button over here on the left-hand side that's got like a quick power of 2. That is really helpful because we use the power of 2 so much. So I'm going to just use that one for my power of 2 and then minus 13. Okay. Now, for those of y'all that if you have a TI-83, this is exactly what you would be seeing in the calculator as you type it in. Okay. For those of y'all that have a TI-84, which is the preferable calculator, the reason why I'm showing you a slightly difference is if you'll notice that on the TI-84, that power of 3, when you hit that caret symbol, it actually puts the 3 up. Just make sure to arrow back down, but you still have that same power of 2 here. Okay, so we're going to hit the zoom 6 and see that standard window. Now, as I take a peek at that, I don't really see much. I mean, do you guys see anything? Okay, so that was our graph. Like, we just don't see anything. So because we don't really see much, I'm going to do some seeing if the second window is better. Let's see what the second window does. So how do I change my window? Well, that's a great question. So let's hit the button that actually says window. Now you'll notice here that the X-min right now says -10, and that's exactly what they told us to be. And the X-max said +10. Now, XSCL is the scale. We're just going to leave it at 1. We don't normally change this. It's very rare when we change it until you get to higher level math. So I would just leave it be unless you just really want to be picky on it. Now, my Y-min is telling me that I should use a -25. So let's type in -25 and make sure you're using the negative symbol down at the bottom right-hand side. And then my Y-max, we said, is going to be 10. So that's exactly what it needs to be. Okay, so again, it's already in y equals. All I'm doing is hitting window and making the adjustments, mainly here at the Y-min, for exactly what I need. Now, once you have all that in there, just hit the graph, and we should see a graph that looks like this. Now, earlier we saw something that said x cubed, and we noted that it had 2 turning points. You'll notice that this one also has 2 turning points. Most x cubes have at most 2 turning points, so it's kind of a good indicator to see there. Okay, so now that we've seen our 2 different graphs, which graph gives the better view? Well, it's kind of obvious when we really sit down and look at it. Which graph actually gives the better view? Well, I would definitely say the one that shows more of the graph and what's going on. So by using that window where we adjusted that Y-min down to -25, we really actually got a better view of that graph. Okay, so in case you're just forgetting which one was which, this is the one. This is our winner. Okay, so seeing that difference, this one right here is that standard window. And the standard window is good for doing a lot of work in math classes, but there's just sometimes that it just doesn't work at all. Okay, let's look at some word problems now. So let's start with suppose the cost of C of removing P% of pollution from drinking water is given by the following model. C equals 5,350 P all divided by quantity of 100 minus P. Okay, and our answer is going to come out in dollars there. Now, we're going to answer the following A, B, and C on it. Let's just start with A first. So A says use the restrictions on P to determine the limitations on the horizontal axis value. Now, here's the thing. A lot of people forget that this is a word problem. And they look at this and they're like, restrictions on P, nothing was stated. Well, technically it was. It just wasn't stated in the way that you were thinking. So earlier in the problem, it said P% of pollution from drinking water. Okay, so we're basically removing a percentage of pollution. Since we're removing a percentage of pollution, it's a percentage. Realistically, we have to think about what is the values on which P could possibly be. So in our case here, if you think about it as a percentage, the highest percentage you can get is 100 and the lowest is 0. So basically we have from 0 to 100. Now, we do want to make a little exception here because if I choose P to equal 100 and I plug in 100 right here, we will notice that it'll end up with some undefined part of the model. So therefore, we are just going to restrict it from 0 to 100, where I'm actually equal to 0, but not equal to 100 itself. Now, that does mean I can get super, super close to 100. So like 99.99999. It just can't be 100 itself. Okay, so we know what we need to restrict P on. So let's talk about B. So B is, I'm going to graph the function on a viewing window. Okay, the viewing window is going to be from 0 to 100 by 0 to 5,000. Now I want to know, why is this a reasonable graph? And why am I actually putting a limitation on my C? Okay, so now this may seem a little confusing because we didn't really talk too much about this change. So earlier we were talking about our X-min and our X-max, right? Now in our case here, I don't have an X, I have a P. So basically think of P as the X, okay? So P and X are kind of interchangeable here. So this first part right here, and I'm going to highlight it so we can kind of pay attention to it. This first part right here was literally what we were talking about. What did we limit our X's to? Okay, or P's in our case. So when I see it written this way, the first thing is going to be basically my X-min to my X-max, or in my case here, my P-min and P-max. Okay, and then they normally say the word by, and then they've got this second bit. Now, earlier again, we talked about the Y-min, and then we had our Y-max. Okay, so the second part in which I'm referring to here that we're looking at, this part right here, the 0 to 50,000, that is going to be my Y-min to my Y-max. Okay, and we can put those in the calculator as we see. Now, it is more often that when you look at problems that they're going to be written in this format where it's just this kind of bracket, number, comma, number, close bracket, by, bracket, number, comma, number, bracket. That's normally when we talk about the viewing window, what it looks like. So let's put this in the calculator and actually graph it. Now, again, I know some of you guys are struggling with the graphing part, so let's take this a little slow here. And remember, you can always pause if you need to. So let's start with our y equals. Now, those of y'all that have a TI-84, you're going to be able to do this here. I'll show you guys for my TI-83s in just a second. So with my TI-84s, if you guys will hit alpha x t theta, now you'll notice here that it shows that kind of nice, pretty like fraction, super nice. And you can actually type it in looking like a beautiful fraction. Okay, now we don't type p's in our y equals, we always type x. So we just have to remember that basically x is p and c is y. Okay, so there we have it. Now this would be kind of what it looks like for my TI-84 people. Okay, so my TI-84 is one of the nice things about having the little bit newer calculator is it actually makes fractions look like fractions. For my TI-83s, I'm sorry, but it's going to be a little bit more difficult in the way it looks for you guys. So what I suggest doing is what you're going to do is type in the top and type in the bottom, but you're going to put parentheses around the whole top and the whole bottom with the division sign in between them. Okay, so again, we're just using that division sign between the top and bottom, but we want to put parentheses around the whole top and the whole bottom, and they'll still give me the exact same graph. Okay, now I'm going to change the color of my graph here. Now, if you feel like you want to change the graph, you're totally welcome to do it. It doesn't make any difference whatsoever what color the graph is. I just want you guys to see the blue one first and then the red one go over it because they end up being the same graph. Okay, now again, we are adjusting our window, so we're going to go to window and we're going to go say 0, enter, 100, enter. Now skip and go down to the Y-min and we're going to say 0, enter, and then 50,000, enter. Okay, again, make sure you skip on those scales. We don't want to touch them. And now we're going to hit graph. And you'll notice if you were watching closely, you saw the blue line go and then the red line go directly above it. So that's why I said it doesn't really matter whether you have a TI 83 or an 84. Either way, they both will write in the problem. It's just my TI 83s. You need to be a little bit more careful and add a lot more parentheses involved here. Okay, so there we have it, and we can see our beautiful graph. So one of the things that the question was asking us is, why is it reasonable to model the graph on a viewing with a limitation on C? Well, the value of C is actually going to be bound below by 0 because C represents the cost of removing pollution. So it's not going to cost me a negative amount of money. I mean, if it costs me a negative amount of money, that means I'm making money by removing that pollution. And we don't normally make money by removing pollution, so therefore it should cost me. So it can't really be negative, which is why we set that limitation to be greater than or equal to 0 for the same reason that we were setting that P to be between 0 and 100. Now, there's no rhyme or reason for why we set the cost to be a high value of 50,000. It's just kind of, we wanted to see, you know, kind of the shape of the graph, and that was just a good high number to get it out there. Okay, so the last part of the question here in part C is find the point on the graph that corresponds to P equals 90. Now we do want to interpret that point to kind of let us know how that corresponds, okay? But we also want to interpret in terms of the word problem that we're seeing. So to help us out here, so everybody should get their calculator. Again, you'll notice this is very much a lot of calculator. So I'm going to do second trace, okay? And I'm going to do, because I know what the X value is, or in my case it's a P, but it's an X value in the calculator, I'm going to hit number 1, okay? And then I'm going to type in 90 and then just hit enter. And that's going to tell me that X equals 90 and Y equals 48,150. Okay, so that's basically what we can do. Now, there is one other way in which you can do this. I recommend this way where you do the second trace option, but if you would like to do the other way, it's not horrible. It's just going to take you a minute. You can always go to second graph and go to the table, but then you're going to have to scroll all the way to 90. And I find that this is going to be a lot quicker if you just hit second trace, number 1, and then type in the X value. You can only ever type in an X value. This doesn't work for the Y values. We have to use a different method there. So what does that mean? Well, remember that X represented our P, and P was 90. So P represents the pollution removed. So this tells us that the cost of removing 90% of the pollution from our drinking water is actually going to be 48,150. Okay. Now, you can see it in the table here, and you can make it look a little bit different. Now, we're looking at a lot of stuff with our calculator, and when we go to second graph, we see that table. You can, again, remind yourself that this table is scrollable. This is the big difference between the two different tables. You'll notice I have a Y1 and Y2. They're technically the same numbers. Okay, the biggest difference here is that this right here was what I did in Y1 and this one was Y2. It depends on how you're entering it into the calculator. Will depend on kind of what you get back out. My TI-83s will only ever get decimals. My TI-84s will pretty much, if you put it in as a fraction, it will stay as a fraction. Okay, And so we can kind of see all the different points that came back out there, and we can see the shape of it. Let's try with another word problem. Let's do voting. So between 1950 and 2008, the percent of voting population who voted in presidential elections during our election years is given by the following function. F of x is equal to 0.0155x squared minus 1.213x plus 75.26. Now, where x is the number of years after 1950, that is the variable, input variable is x equals 0, represents the year 1950. Now I'm going to highlight that because that's super important for us to make note of. This right here, I said it earlier, but where x is the number of years after 1950, this type of statement is going to show up quite a bit in this course. So you definitely want to make sure that, remind yourself that what this represents, that this right here is basically telling me that x equals 0 is the year 1950. So the first question we want to know is basically what are the values of x that correspond with the years 1960 and in 2008. Again, this part that I've highlighted is very important. And again, I'm asking about the values of x here. So when I'm talking about those values of x, you've kind of got to go back up and read up here for kind of this statement. Like I said, it's almost always written in there. Okay, so let's talk about with 1960 first. So how many years have passed since 1950 to get to 1960? Well, it looks like 10. But what about 2008? How many years have passed since 1950? Well, in our case there, that's going to be 58 years have passed. So instead of using 1960 and 2008 into my functions, I'm going to use x equals 10 and x equals 58. Okay, so let's try that with the 10 first. So let's find f of 10 and explain its meaning. So as we are going to look at that, the first thing I want to remind ourselves is we're going to substitute 10 into the formula. Now, you can again do this by hand, but these are some big decimals. So if you want to stick it in the calculator and let the calculator do the math, that is perfectly fine. So just make sure that when you're plugging in for that variable that you're putting parentheses around it. So our f of 10 is going to give us a 0.0155 times 10 squared minus 1.213 times 10 plus 75.26. And when I add that all up together, everybody should have gotten 64.7. Now, how do I interpret that? Well, again, let's remind ourselves that x equals 10 corresponds to the year 1950. Now, f of x corresponds to what? Well, somewhere in the problem, it says blah, blah, blah is given by f of x. So it's probably above this. The percent of voting population who voted in a presidential election. So this represents the percent of voting, I'm going to abbreviate population, who voted. Okay, now given this is in during a presidential election and during the years in which they're running. So we can say that approximately 65%, because basically 64.7 rounds to 65, voted in 1960. Okay. Oh, I made a 1960, because 10 years, x equals 0 represented our year 1950. And this one was 1960. So we can kind of see that. Now let's try this again, but with 2008. Okay, so let's talk about, is this model actually going to be accurate and what would that percentage be? So let's use x equals 58 into the formula. And again, this is basically x equals 58 is representing that beautiful year of 2008. Again, we don't like to type in big years, we want kind of smaller numbers. Now, when I plug it in, I end up getting 57. So if the model is accurate, okay, so if it is accurate, approximately 57% of our voting population voted in the 2008 presidential election. We're going to say the model is going to be pretty accurate here because it does say that it should work between 1950 and 2008. Now, if they had told me, say, 2012 and used this, I can't really say that this model will be 100% accurate because the model we've given is only valid for those years. Okay, so again, with those technology notes, just remind yourself that once input values for viewing windows have been selected, trace or the table is going to be the best way to get your output. Okay, so output values, AKA those Y values. Okay, let's try again with another word problem. And again, guys, do remind yourself a lot of this is a lot of word problems and we do kind of have to work our way through some of these. So we're going to use a viewing window with the values representing the ages from 20 to 65, and we're going to graph the function with a graphing calculator. So what's the function I need to graph? Well, millions of Americans who are working full-time at selected ages from 20 to 65 can be modeled by the following function, where their age is X. Now, a model is basically Y equals a negative 0.000362 X to the third plus 0.0401 X squared minus 1.39 X and plus 21.7. Now, once we've done that using the viewing window, we're also going to model to estimate the number of Americans with that age, okay? Now, for the viewing window, let's talk about this. This is where we're gonna kind of have to play with a little bit. And it just ends up getting a little on the crazy side when we go through these ones here. So let's just start with plugging this in the calculator and let's play with it this way. So I've already got stuff in there, so I'm going to hit clear out. So we're going to clear it all out. And we're going to go back to the Y1 part, so Y1. And I'm going to type in this part here. So negative 0.00036 X to the third plus 0.0401 X squared minus 1.39X plus 21.7. Now, remind yourself that basically right now our viewing window was the last window that we looked at. So right now it says from like 0 to 100 and then 0 to 50,000. So if you want, hit zoom 6, and what that's going to do is change everything back to the standard window. Okay, now when you do the standard window, the first thing you're going to begin to notice is you don't see anything. Okay, and this is very, very common when using a calculator to do a couple things. You might not see something. So what we want to do here is we're going to go back to the window, and remember that it told us our X ages had to be between 20 and 65. So let's change this to 20 to 65. And let's see if that makes any changes. Okay, so I'm just going to hit graph here. And that definitely made a change. Now I am beginning to notice that my Y values are up here, but not down here in the negative. So let's go back to our window and let's go, okay, for my Y min, let's just put it at 0. Now let's think about this. Remember that X is my ages, okay, but my output is the millions of Americans who are working between those ages. So I shouldn't have negative people working. So that makes sense why I'm going to rule out those negatives there. And now when I hit graph, I can see that graph a little bit better and really kind of see that shape of it. Okay, and this is where we can kind of make those adjustments again. Nowhere did it tell me what those Y values needed to be, but it was one of those things that we do have to kind of play with it a little bit and see whether or not what's working and what's not working for our graphs itself. Now that we've got our graph in the kind of format we want to see, we do need to make a bit of adjustment for part B. Part B says use that model to estimate. Now, remember, we're estimating for the ages of 55 and 64. And we have two different ways in which we can do this, okay? The first way, and again, I kind of wrote this down here, so just so you guys can see it, okay, and I'll let the calculator disappear in a bit. But one of the things that you kind of want to do is I recommend strongly to do the second trace method, especially if you know that X value. So basically second trace, choose number 1 for value, and then you're going to type in the age. Okay. Now you can repeat the process again. So here we are. Make sure you write that Y value down, and then second trace, again, number 1, and then we do 64. Okay. Again, noting that Y value there. Whatever you do, don't hit just the trace button, because you'll notice here that this is not exactly 64 and the answer becomes a little bit different. So yeah, you can do the trace button, which kind of gives you an idea of like where the number is, but second trace number 1 is going to give you the most accurate way to actually get the answer. And it really makes a bit of a difference there. Okay. Now, the other option is by hitting the graph and go, instead of taking a look at the graph itself, go to second graph and go to the table. Now, in this case here, you are going to have to go find 55 and 64, which I don't recommend just because it's a lot of scrolling, but it's totally possible. And if you found them there, it's going to be a 6.324A, or in 64's case, it's going to be a 2.0935. Again, kind of your choice of how you want to do that, but whichever way, I recommend the trace over the table just because it sometimes takes longer on the table to scroll. All right, let's look at another problem. So with this problem here, let's talk about the number of US adults with diabetes in thousands projected to 2050, and it's shown in the table below. First thing we're going to do is we are going to align X equals to the number of years after 2015. Okay, so what I need to do is actually kind of make some adjustments here. Now, as we make those adjustments, what we're going to do is we're definitely going to play with the calculator quite a bit here. So, okay, so since the first thing we're going to be doing is a lot of calculator set, and you'll notice I say put it in list 1. So what exactly do I mean? This is basically the steps for making a scatter plot. So let's start off by second quit. So I know we've got stuff here in Y equals, so let's go ahead and clear it out. And then just second quit back to the home page. Make sure you've got nothing in the home page. Just kind of start with a fresh calculator, which is really nice, okay? So what you're going to do is hit the stat button, and then we're going to say edit. Now, if you have stuff in there, we're going to clear it out. So go up to list 1 and clear it, and then go up to list 2 and clear it. Do not hit the delete button. If you hit the delete button, you're actually deleting the list. We don't want to delete it. We want to clear it. Okay. Now, remember I said there was something very important that we had to pay attention to as we were looking at these. And the first thing is X is the number of years after 1950. So that is basically my 0 year. Okay, so keep that in mind. That's very important there. So for this first year, I'm going to have 0. Now, if you're not sure how many years have passed, what you can do is you can actually type in the year and then subtract out what your starting year is. So if you don't see it, then you can actually have it do the math for you. So, 2025 minus 2015 is 10 years. Okay, hopefully you're seeing it now. And you're kind of beginning to see what's actually happening there. And again, don't always assume. I know that some of you guys are looking at this and going, oh, well, it changes by 5s every year. Well, in this case, it's changing by 5 every year. That is not always the case when we look at these, okay? Once you've got all of your list 1 in, you're going to move to list 2. Okay, don't worry about the commas. We don't want any commas actually in there. That actually, the comma in the calculator represents really more, not necessarily the number side of things, but to let us know the difference between 2 commands in the calculator. So we use it in statistics, but we don't use it in this class. And once you've got it all entered in, that's going to be totally great and awesome. Make sure that everything is correct. So go back and double check everything. That's very important. A lot of students, that's where they make their mistakes, is they don't go back and check. The second thing you want to look for is, you guys notice I'm kind of pointing it out here, is these dotted lines down here should line up. If they don't line up, you're going to get a little bit of an issue. Okay. So now you've got everything in list 1 and list 2. That's the first part of the steps here. Okay, so we're just making sure that we line it up and put them in list 1 and list 2. Again, almost always list 1, let me go back a slide, sorry. This year will almost always be list 1, and then whatever is the output is almost always list 2. It's very rare when it's the other way around. Okay, so now that you've done that, now we're going to create a scatter plot. So you've already put all this in the calculator. Now we're going to create our scatter plot. So what we're going to do is we're going to go to second y equals, go to our scatter plot number 1, hit enter to execute. On is flashing, so we want to turn it on by hitting enter. And then everything else should already be set up, which would be really nice. And then we're just going to hit zoom, and then we're going to hit number 9, because that's going to be the stat one, and that's going to basically, the calculator is going to do the window changing for us. And there we have it. We've just created our first scatter plot. Okay, so when you plug stuff in, as you can see, like this is basically what you see when you start plugging things in. And then this is what you see when you start putting the scatter plots. Now, one of the things is you'll notice slightly different here is what I did here versus what I did here. But the graph looks very similar. So one thing that you want to be aware of, and I'm going to go back to the list real quick, is you'll see here how I type stuff in and here how they type stuff in. You want to be super, super careful, okay? So the first thing is, you notice I have a typo because I put in the wrong number here. That's definitely going to throw it off later on in the semester. The second thing is you always want to ask and read closely whether or not they want it in with all the zeros or if they want the short versions of the numbers. It's very important to kind of make note of that as you're going through these problems, okay? So as you're doing that, that's going to be something that we end up taking a little bit further along the way. So as you can see, list 1 represents those years, but again, we always do that kind of realignment. And then list 2 is going to represent our money. Now, again, just be careful. Is it asking it to be in thousands, or is it actually asking to be written fully out? If it's asking for it to be written in thousands, which you can kind of see here, we do need to make some adjustments to it. And so it would be 27,000.3. Again, this one here is 50,000.0. That third one is 59,000. Notice for 1,000, I'm putting that decimal, okay? So when I say the word 1,000, I say decimal, and then I type all the numbers after it. So that's where, as you take a peek at it, it is slightly different, depends on how they want it. If they don't say anything about it, you just type the numbers in just like you would, okay? If they do say like a certain way that it has to be written, then just make sure to write it that way that they state, okay? Now, once you've typed them in that way, you'll notice that, again, even though I've changed my list 2 to something different, I'm still going to go back up here, second y equal, make sure this is on. If it's on, you can bypass this stuff and then just go to zoom 9 and it rearranges it. But even though I changed it from the different thousands to this, all it did was basically lower the numbers to make it a little bit more realistic on a graph. Okay, you've now created your first scatter plot. Make sure you make good notes because we'll be making scatter plots throughout this course and taking it a step further. If you have questions, make sure to reach out to your instructor.